I will explain a for loop which is used to iterate over a sequence such as the list. The for loop executes a set of statements for each item in the list and stops at the end of the sequence. I'll use a for loop example from a code block that creates a line graph that shows the retreat of the Columbia Glacier in Alaska from 2015 to 2019 using transects to measure the retreat. We create a list of numbers from 1 to 23 that corresponds to the numbers of transects, with a section of code below specifies the colour map that we will iterate through to assign colours to our transect lines. To plot each transect, we will employ a for loop. A for loop is a good choice here because otherwise we would have to write out the same code 23 times, once for each transect, in order to add it to our graph. If we utilise a for loop, we only need to specify what we want done once, and the code will iterate through all the transects in the loop until each one has been added to the graph. First, we iterate through the members of the numbers list. The argument enumerate returns a pair of values. One is the index, which is transect, and one is the associated value. By default, Python starts with a value of 0 unless you specify otherwise. Here we specify that the columns start with 1 by writing transect plus 1. If we excluded this line, the code wouldn't run because there is no transect 0. However, transect is a number at this point, and our column names are actually strings, even though they superficially appear as numbers. We therefore need to stringify the number 1, so we specify that a new object, column, is the stringified version. Python wouldn't recognize the number 1 in this situation if it was an integer because the column headings are strings. The next line filters our data frame. We only include the data from our transect columns that fall within our desired date range, which is specified with a Boolean statement, i.e. if it's true that the data falls within our specified dates, we will include it. If we excluded this statement, we will get all dates plotted on the graph. Y1 therefore ends up as a data frame with 23 columns and as many rows as there are values that correspond to our date range. C equals next color refers back to the color command above to make every line a different color based on the color map. Finally, we plot our data using the X and Y1 data frames. The name of each transect in the legend is defined by the column object, i.e. transects 1 through 23. The line width of our lines in our line graph is 1. The colors are defined as C from the line above. We can change these parameters if we wish to make the graph look different. We add a line of code to plot the average transect extent as well in our graph. We set some plot parameters. Finally, we show the plot. In our second example, we are looking at a code block that plots an ocean shapefile in the Vancouver region. The first line sets the Mercator projection as default using the Cartopy package. The next line specifies the size of the figure, then that the axes should be plotted using the default Mercator projection. Next, we set plot parameters, such as the extent of the axes, using predefined longitude and latitude values. We specify our coordinate system as geodetic. Line style specifies how to add grid lines to the plot. In the for loop, we are iterating through the geometries in the ocean shapefile. My feature is the variable that takes on the geometries in each iteration of the for loop. The only statement to be executed in this for loop is to plot the shapefile geometries. Ax.add geometries adds the spatial information from the shapefile to our plot. The plate carriage projection treats the Earth as a flat plane in which our shapefile spatial data is projected. It differs from the Mercator projection because the Mercator projection treats the Earth basically as a sphere. Face color specifies the background color, and if we remove this background is a different color. Edge color specifies outlines, and alpha refers to the transparency.